In this example, I ask you to determine the slope of the line whose equation is negative 3x minus 4y equals negative 20. 5 options. Write out this slope formula. Divide both sides of the equation by this negative 3. Move over 3 and up 4 on a graph. Sketch the point negative 3, negative 4 on a graph. Or give me your 1 finger through 5 fingers. What's your preferred strategy? They're getting more challenging now. All right, so the 2 favorite options are 1 and 5. So somebody tell me if you picked option 1. Let's suppose that we write that slope formula out. And I guess it's already written out right here. What do you then do with that slope formula? If you chose option 1, where are you thinking to go from there? So you write that slope formula down. At that point, you've sort of put everything that you know about slope on the page, and then you move on to the next problem because you're not sure where to go. Yeah, so the slope formula is important, but it's not a be-all and an end-all, right? It defines slope, but it only defines slope if we have what kind of information? We can only use this slope formula if we have 2 points, right? If we know what the points x1 and y1 and x2 and y2 are. If we know 2 points, that's when we want to use this formula. But we don't know 2 points. We don't know the coordinates of 2 points on this graph. We only know this equation. And so the slope formula, while it's relevant, is not helpful in this problem. So somebody that chose option 5, why did you choose 5? What is adding 3x to both sides of this equation going to ultimately try to do for us? Yeah. Yes, right. So there are 2 ways that we can get the slope from a linear equation. If we know 2 points, we can use the slope formula. But if we don't, we can extract it from the slope-intercept form of the equation, y equals mx plus b. And so your ultimate goal in this problem is going to be to try to turn this equation into a form that looks like y equals something times x plus something. And I can do that by solving for y, getting the y by itself. Right? If I get the y by itself, then whatever is on the other side of that equation is my mx plus b. And once I get my mx plus b, where's my slope?
Already in front of the x.
In front of the x, exactly. So if I'm looking for my slope, this is where I'm going to find it. Once I've solved for y, the coefficient of x tells me the slope of this equation. So my ultimate priority is to solve for y, and in order to do that, my most effective first step is to take this negative 3x and to somehow move it over to the right side of the equation away from the y, because we're trying to get the y by itself.